Today we are going to characteristic polynomial and Cayley-Hamilton theorem. It is a topic under linear algebra. So, according to Cayley-Hamilton theorem, it states that every matrix A is a root of its characteristic polynomial. That is, every matrix, once you have gotten the characteristic polynomial, so the matrix itself is a root of that characteristic polynomial. Root means when you slot in the value, of the matrix into the characteristic polynomial, it will give you 0. That is the meaning of root. Because the root of a function, when slotting into the function, gives 0. So, according to Cayley-Hamilton theorem, it says that every matrix A is a what? Root of its characteristic polynomial. Now, let's dive into calculation. Example 1 says, let matrix A, this is matrix A, to be 1, 3, 4, 5. As you can see, the question says, find the characteristic polynomial. Then 2 says, verify Cayley-Hamilton theorem. Now, let's go. Solution. Solution, as we can see here, as we can see that we are given matrix A as 1, 4, 3, 5. As you can see. Now, the first question says find its characteristic polynomial. Please, don't forget that under eigenvalue and eigenvector, naturally we used to use A minus lambda I. Then from this, you will now find the determinant of this. Determinant of this will now give us what we call characteristic polynomial. But I want to use another method here. And the method is very, very easy. Now, the formula for the method, it says characteristic polynomial. This is the general formula for the shortcut for 2 by 2 matrix, 2 by 2. It says characteristic polynomial is equal to c squared, it is fixed, c squared, minus the trace, of the matrix, which is trace of matrix A. This TR means trace, plus the determinant of that matrix A. This is the shortcut for the characteristic polynomial. This is the formula pattern. Now, don't forget, notes, because it can be confusing, notes that the eigenvalue is equal to t. In this case, the eigenvalue is equal to t here. So instead of writing eigenvalue, we are representing the eigenvalue as t. Now let's go into the calculation. Now we need trace and we need determinant of matrix A. What is the meaning of trace? Trace of A. It means we have what we call principal diagonal. This is the diagonal, or we call this leading diagonal, but it's basically from the diagonal like this. So this 1 and 5, they are under the principal diagonal like this. As you can see, this is the diagonal like this. So we are going to add them together. So the trace of matrix A will now be the addition of the element in the diagonal, which is 1 and 5. It will now be 1 plus 5. What is the answer? 6. The 6 is the trace of matrix A. As simple as that. Now, for the determinant of matrix A, depth of A, determinant of matrix A, which we can also write it as this. Determinant of matrix A, same thing. So it is equal to, now this is the matrix. We will now write the symbol of determinants. 1, 4, 3, 5. We find the determinant of the matrix. So which is actually equal to, determinant will be this times this, which is 1 times 5. 5 minus 4 times 3. That was what? 12. Which the answer gives minus 7. Which means the determinant of matrix A is minus 7. So, in conclusion, since our characteristic polynomial formula, it says it is equal to what? C squared minus trace of A multiplied by T plus determinant of matrix A. Note, I'm using matrix A because I'm given matrix A. If you are given matrix B, use trace B. If We are given matrix W, trace W, determinants W. And observe something again. We are alternating the symbol and the sign. Plus, this one is always plus. Plus, minus, plus. Plus for the t square, minus for the trace, then plus for the determinant. So I'll just plot in the values into the characteristic polynomial formula, which is t squared. What is the trace? The trace is what? 6 minus 6 at the trace of a. Then there is t there. You put the t plus determinant of a is what? Minus 7. Bracket minus 7. But because plus times minus is what? Minus. So the characteristic polynomial will now be t squared minus 60 minus 7. That is the characteristic polynomial. Question Roman figure 1. Now Roman figure 2 now says verify Cayley-Hamilton theorem. According to the theorem, it says that every matrix A is a root of its characteristic polynomial, which means this matrix A is a root. What is the meaning? It means that if I slot in, it means if I represent this T as my matrix A and I slot in the value into this is our characteristic polynomial. So it will give me 0 because it is a root. And every root, when slot into a function, gives 0. So let's test that. Let's confirm that. So it's because I'm given matrix what? Matrix A, which means it will now be what? It will now be f of A. Why is it f of A? Don't forget that for every polynomial is like a function. So for me to use A, I have to make it to be a function, and this is still this. So it's equal to A squared minus 6A minus 7. I'm still writing this. So according to Cayley-Hamilton theorem, I will now, don't forget that our A is what? 1, 4, 3, 5. So I will now slot in the value to show that Cayley-Hamilton theorem exists, or it is real, that the matrix A is the what? Root of its characteristic polynomial. I will now use f of A will now be equal to, what is my A? Is what? 1, 4, 3, 5. There is squared. Don't forget, I'm following this. Minus 6, bracket. Now, I remember something here. Please, there is no way you can subtract a number or add a number to a matrix. It is not possible. So, for me to add or subtract a number from a matrix, I have to give it what we call identity matrix, I. Ordinary 7, you cannot subtract it from matrix. So I will now put I here. I'm still writing 7. The I is called identity matrix. Minus 6 brackets. What is my A? 1, 4, 3, 5. Let me clean this. Then minus 7. Bracket. Note, identity element for 2 by 2 is 1, 0, 0, 1. 1, 0, 0, 1. I'll just expand. If I now expand it, so you know this is squared, and it's in 2 places. It will now be 1, 4, 3, 5 multiplied by 1, 4, 3, 5. That's the meaning of that squared. Then minus 6 bracket 1, 4, 3, 5 minus 7 bracket 1, 0, 0, 1. Then I will now expand. Now let me expand here. Now from here now, it will now be what? If I want to expand 2 by 2 matrix or any matrix, it will be row by column. First row, first column. 1 times 1. Which means f of A is equal to 1 plus, because 1 times 1 is 1. Plus 3 times 4, that is first row, first column. 3 times 4, 12. That is 1 plus 12. Then I will now go to first row, second column. 1 times 3. That is what? 3. Plus 3 times 5. That is first row, second column. 3 times 5. That is what? 15. As we can see, I'm done with that part. I will now go to what? Second row, second row now, first column. Second row, first column. 4 times 1, 4. Plus 5 times 4. That's what? 20. That is second row, first column, as you can see. Now, second row, second column. 4 times 3. That is what? 12. Plus 5 times 5. That's what? 25. Then we close it, as you can see. Now, 6 times 1. You know there is minus there. Just put the minus outside. 6. 6, because the 6 will open the bracket. 6 times 3. 18, as you can see. 6 times 4. That's what? 24, as you can see. And 6 times 5. That is what? 30, as you can see. You close it. The cell will open the bracket. Minus bracket 7 times 1. 7. 7 times 0, 0. 7 times 0 is 0. 7 times 1 is 7. The next thing is to add and subtract. So the f of a will now be equal to what? 1 plus 12, 13, 24, 18, 37. Now, we can say okay, we can do it in 2 ways. We can first subtract, but let's just write it out first. Minus bracket 6, 18, 24, 30, minus bracket 7, 0, 0, 7. Okay, 13 minus 6, that's what? 13 minus 6 gives 7. 18 minus 18, that's what? 0. 24 minus 24, that's what? 0. 37 minus 30, that's what? 7. Minus, what is here? 7, 0, 0, 7. If I now subtract, it now give me 7 minus 7, 0, 0 minus 0, 0, 0 minus 0, 0, 7 minus 7, that's what? 0. So as you can see, therefore, my f of a is equal to 0, 0, 0, 0. Since it gives 0, which means I can just say my f of a equal to 0. Or I can just say it is what? 0, 0, 0, 0. Since it gives me 0, then it is what? Cayley-Hamilton theorem is verified, which says every matrix is a root of its characteristic polynomial. Since it gives 0, so it is a root. That matrix A is a root of that characteristic polynomial. So as simple as that. Thank you very much for watching. If you have any question, you can drop it on my DM. If you have any question in this topic or any other topic, thank you very much. Please subscribe, like, comment, and share.